Hello, we're looking at symmetric difference of two sets. Now, the first time I talked about difference of two sets, which is also known as relative complement. Now, let's look at symmetric difference, not just difference. Is it clear? Now, symmetric difference of two sets refers to the elements that are in either of the sets, but not in their intersection. Symmetric difference of set A. Now, the symmetric difference is denoted by something like this, a triangle like this, a smaller one. Symmetric difference of A and B, A symmetric difference B, do you understand? Is given by all the elements in either set A and set B, but not in as in those ones that we can find in both. I don't know if you understand what I mean. That if there is an element in A and there are elements in what B, those ones are the ones that we are going to write. But those ones that we can see as the intersection of A and B, that are not included. Do you understand? So mathematically, symmetric difference of A and B is given by A union B minus A union B. Let me remove this curly bracket. I'm just introducing a formula. A union what? B minus A intersection B. So it means that for you to even understand this symmetric difference, you need to understand what we mean by union. You need to understand what we mean by intersection of two sets. Is it clear? So we've seen, watch out now. If I have that set A, let's make it fast. If I have that set A is has the element 2, 5, 8, and what 9. And I have that set B has the element 3, 6, 9, and 11. Then they ask me what is A symmetric difference of B. Now, for my definition, I said that symmetric difference of two sets refers to the elements in any of the sets. Do you understand? The unique elements in any of the set, those ones that are in any of them, but not in their intersection. Now, you can see the intersection of A and B. Intersection of two sets means what you can find in both sets. The elements you can find in set A and in set B. Now, I can see 9 here. I can equally see 9 here. So the intersection of set A and B is 9. Do you understand? So that means that you can see 2, 5, 8. I can't find it here. Neither can I find 3, 6, what? 11 here. Therefore, we can say that the symmetric difference of what? B will now be what? Union, we have 2, okay, we have 2, 3, 5, 6, 8, and what? 11. So symmetric difference of two sets means remove the intersection, which is remove the intersection of the two sets, the union whatever elements you have. I hope you understand. So if I want to solve this now, if I want to solve this question using this formula, what do I have to do? I must first of all get what? A union what? B. Union of two sets means collection of all the elements in the two sets without repetition. You don't repeat any element. Now, union in set A and B. Now, what I have to, that's write all the elements in set A and B. That's what union means. I have 2, 3, 5, 6, 8, 9. You can see that 9 appeared 2 times, right? But we are writing only 1 because I said without repetition. Does it make sense? Now, I've gotten A union B as this, right? Now, A intersection B. Intersection of two sets, because I'm trying to use this formula. I must get this and get this. I've gotten this as this. Then, A intersection B means what can I see in A and B? Means common things, common elements that I can see in A and B. And that is 9, as we've seen earlier. Does it make sense? So the symmetric difference now means this minus this. That's the element that you're having here, remove it from here. So I'm having 9 here, right? This 9 that I'm having here, I'll remove it from here. So you see that the symmetric difference, according to this formula, is now what we got earlier, which is 2, 3, 5, 6, 8, and what? 11. And is that not what we got earlier? It is. So you can use this formula. Note that symmetric difference of two sets is given by this formula. Or you say that symmetric difference refers to the elements that you have in either of the set, in the set one by one, but those elements that falls in their intersection, you don't include them. That's what we mean by symmetric what? Difference of what? Two sets. I hope you understand. So I'll give you a question. Please try as much as possible to write your answer in the comment section. So if I have that set P has the element y such that the elements in y, that's y is as in -2, which is less than or equals to y, and y is less than or equals to, let's say, 10. It's less than 10. That's what I mean. Then I have that set what? Q has the what? Element. First six. First six what? Prime numbers. So the elements in set Q are first six what? Prime numbers that we have. Then set P is having -2, which is less than or equal to Y, and Y is less than 10. Give me the value of P symmetric difference of what? Q. Does it make sense? I hope you understand. So give me the answer in the comment section. Please have a nice day. Like, comment, share, and follow Kosis Academy. Please try as much as possible to do what I ask you to do. Bye bye.